In these problems, we need to determine the number of ways in which the World Series can be completed under certain sets of circumstances. So let's start with question 1, and it says, suppose Team A wins the first 3 games. How many ways can the series be completed? And then we want to draw a tree for that. All right, so if Team A is going to win the first 3 games, then I will start with only Team A winning, right? It's the first 3 games. So this is A winning, and then A winning. So there's just one way for this to happen so far. Now, at game 4, we could have Team A win again, or Team B could win. Now for game 4, either A will win and then win the series, so this is going to stop right here, or Team B will win a game. Now let's suppose that Team B wins game 4. Now in game 5, again, either Team A will win or Team B will win. There we go. And if Team A wins, again, we're done. And if Team B wins, now we're 3-2. So we go into game 6, and Team A could win or Team B could win. And if Team A wins, then we're done. And if Team B wins, now we're tied going into game 7. And for the final time, either A could win that game or B could win. And there we go. So let's see what we have going on here. So here's one end of the tree. So this is a terminal vertex. We're going to see that in chapter 10. Here's another terminal vertex, one that doesn't go any further down the line. And 3 and 4 and 5. So there are 5 ways for the series to complete if we have Team A winning the first 3 games. Now let's take a look at number 3. In this case, it says, how many ways can a World Series be played if Team A wins 4 games in a row? All right, so let's see. In this case, either Team A or Team B could win the first game. But since we're assuming that Team A is going to win 4 games in a row, what that tells me is that if Team A wins game 1, then Team A in this scenario is going to have to win the next 3 games, because Team A is going to have to win 4 in a row, and the only way to win 4 in a row is to, because that'll be the end of the series, so you couldn't win 1, lose 1, and then win 4 in a row, because they wouldn't play 4 in a row after that, right? So this is A, and A. All right. What if Team B won the first game? Then we have 2 possibilities. Either, of course, Team A wins or Team B wins. Now let's suppose Team A wins game 2. Again, Team A is going to have to win the next 3 games, because we know that Team A is winning 4 in a row. And if Team B wins game 2, then there are 2 possibilities. Team A or Team B wins game 3. So if Team A wins game 3, then Team A is going to have to win games 4, 5, and 6 as well. Getting closer to the end. And if Team B wins game 3, then again we have 2 possibilities. Oh, do we? We don't. Because we do, in the problem it says Team A has to win 4 games in a row. So if Team B wins on game 4, then Team A is never going to win, and that doesn't satisfy what we have in this problem. So if Team B won game 3, then Team A must win game 4, and game 5, and game 6, and game 7, and that would be a very exciting series because Team B would figure they had it won, and then A comes out of nowhere and wins the whole thing. Okay, so how many possibilities is this? So how many terminal vertices for this graph? 1, 2, 3, and 4. So 4 possibilities for this one, and the previous one, what did we count? 5. So there you go.